Okay. So standard deviation contest, you don't see these at your low. We maximize the standard deviation. Okay. Then we move to this guy, right? Then we move to this. And I decided I would come up with some numbers that are similar to what we see in the histogram, okay? So look at the numbers that I've chosen for variable A and the numbers that I've chosen for variable B. What's different between variable A and variable B? There are more fives, okay? Do you see how this reflects what we see in the histogram? It's not exactly the same, but it's the same idea, right? More values in the middle, more values equal to the mean, right? So there's a greater frequency of values. So look at the height. We really did have to look at the y-axis for this problem to see that it's very common to see a value that's equal to the mean or very close to the mean. In variable A, it's more common, more frequent. I'm looking at the heights of the bars to see values that are farther from the mean, okay? So when we look at these distributions, a simplified version of that histogram, we can see that the mean is both 5. That's true for the histograms as well. Now let's just look at overall absolute values of deviations from the mean, okay? 3 is 2 away from the mean, right? 4 is 1 away from the mean. 6 is 1 away. 7 is 1 away, or 2 away, sorry. Same deviations, same values of deviations for variable B, but the values in the center occur more often. You guys with me? Yeah. So if I list all of those deviations, so variable A and variable B, they look kind of like this. See all the zeros? What does a zero mean? Remind me? No deviation. That means that value, there's no deviation, that value is exactly equal to the mean. So it's a deviation of 0. Now, if we were to add up all of these deviations, we get 14 over here, I believe. 13 over here. I'm talking about the values of the deviations, right? So I've got 2, 4. 14. Thank you. It is 14. 14 is the sum. I'm just going to say sum of absolute deviations so we can get used to these symbols. And then I've got the sum of absolute deviations over here. That equals 8, I believe. Okay? So let's just average it, right? There are 13 observations, so I'm going to get 14 over 13, the total number of deviations that I have, 1 point something or other, something.
3 maybe? 1.077.
Okay, we'll do 1.08, and then over here we're going to divide by the number of observations, and we should get 8 over 13 something, 0.612. Okay, 0.62. So it's not the right way to calculate a standard deviation, but it's a little more intuitive. Talk to me about why the standard deviation is larger for variable A. I want to hear you articulate it, and then I'll repeat it. Brendan, please.
The standard deviation for variable A is larger, or it'd be larger.
Yes.
Larger than variable B because in variable B the numbers are more concentrated in the center by the mean. In variable A they're more spread out.
Nice, nice. Great. So standard deviation for variable A is larger because in variable B, as you said, the numbers or the values are more concentrated around the mean. Okay? We see more of these zeros, values exactly equal to the mean. So do you see how this simple example reflects what we see in the histogram and why we need to choose variable A as the one that has the biggest standard deviation?
Yeah.
Yes? Can everyone nod or look at me and say, yes, senior stats master, I understand?
Creative type.
Okay, Haruka, makes sense? Fuka? Yes. Shangfu? Yes.
Is it like safe to assume that generally when you see like a graph like that and a graph like that, they're trying to trick you and you should look at the
I don't think it's a trick. I don't think anyone's trying to trick you. I think they're trying to make sure you fully understand the idea, the concept of standard deviation.
But like
Okay.
people are gonna look at that, they're gonna think, oh, the deviation of variable b is larger, even though it's really not. I feel like that's kind of a trick.
I don't see that, but if you understand this really well now, then you will never be tricked again. Okay?
It's just because the more value is closer to 5 on variable b than on variable a, right? So
Okay. So remember, we're not looking at the values themselves, we're looking at the deviations of the values from the mean. Okay?
so there's more variables deviating from 5, I should say.
In variable A. Good. Yeah. That's good.